All right, today we tackle the quadratic formula. Quadratic formula is a way we can solve any quadratic equation. So far we've solved quadratic equations by making them equal 0, and then we factored and used a zero product property. And then our two answers, or sometimes one, but usually two answers, gave us the x-intercepts or solutions to the equation, x-intercepts of the parabola. But what if that polynomial was not factorable? What if it was a prime polynomial? Remember we saw some prime polynomials when we did factoring? The quadratic formula can still solve that. You're just going to get not very nice numbers for answers. So you can get all kinds of answers from these quadratic formulas, from solving using the quadratic formula. Some of our answers, like you've gotten all along, are integers, like +7, -2. They're real nice numbers. Some of them are fractions or decimals that are going to terminate or repeat, rational numbers, like a half or 7/4 or -2/3, something like that. They're not too bad. We've gotten those answers too, we factored. Some of our answers, if we can't factor, if we have a prime polynomial, are going to be irrational decimals. Those are decimals that never terminate, never repeat. They go on and on forever. These are going to come from radicals that are not perfect squares. Square root of 70, for instance. If we get those decimals, we're going to round to either the tenths place or the hundredths place. It all depends on what the directions say. Sometimes they'll ask you the tenth, sometimes they'll ask you the hundredth. And you're going to find out that some equations have no solutions at all, because a parabola has no solutions, or x-intercepts. You've seen that when the discriminant was when the discriminant was negative. Discriminant is negative, you have no solutions. We talked about that last week. So the discriminant is actually going to be part of our quadratic formula. So without further ado, let's take a look at the quadratic formula. Drum roll. If you're ever going to get a tattoo, this is a great one to get. I got it tattooed on my shoulder, my right shoulder blade. Here it is. X is equal to -b plus or minus, there's that symbol, the square root of b squared minus 4ac, and that whole thing is all over 2a. Well, inside that radical, there's our discriminant, b squared minus 4ac. And check this out. -b over 2a, that's the equation for the axis of symmetry. So you've seen that too. And then this plus or minus symbol, that's what we're going to use to get two answers. We're going to do -b plus whatever this is, divide by 2a. That'll give us our first answer. And then we'll do -b minus whatever this is, divide by 2a. That'll give us our second answer. So the formula's got a lot of different parts. Sometimes the calculation can be very confusing because of order operations, and the way you put it into whatever you're using to calculate could get you a wrong computation based on the order of operations. So as we go through these, I'm going to give you some hints, and remember, just be really careful. So let's take a look. First things first, we have to make sure the equation equals 0, which this one does. So that's good. Because this formula has so many little parts, I like to make a list of what the A, B, and C are before I even start putting numbers in place. It just means there's one less thing you can do wrong, hopefully. So this equation, A is equal to 1, B is equal to -2, and C is equal to -15. And now I'm going to take my numbers and put them where they belong. So x is equal to, formula says -b. Well, b is already negative, so remember, just like in the axis of symmetry formula, if b was negative and it was a -b, when it goes in, it becomes a positive. Plus or minus the square root of b squared. Just like when we did the discriminant, I'm going to square that first. Remember, you square anything, it becomes a positive. So a -2 squared becomes +4. Minus 4 times a, which is 1, times c, which is negative 15. And that whole thing is all over 2 times a. Well, a is 1, so right away that's a 2. All right. Now let's do some calculations. First thing you have to do is computate inside the radical. See what that's going to give you. The square root of 4. Well, negative times negative gives you positive. 4 times 1 times 15 is 60. And that's all over 2. I'm going to slide up here just for some space. So that's equal to 2 plus or minus the square root of 4 plus 60 is 64 all over 2. Well, that's real nice because 64, that's a perfect square. The square root of 64 is exactly 8. So it's going to make my answers really nice. This is where I use this plus or minus symbol. So now I'm going to take this, I'm going to split it up into 2 separate answers. One using the plus. So it'll be 2 plus, well, that square root of 64, that was 8 over 2. And 2 plus 8 is 10. 10 divided by 2 is 5. And over here, I'm going to use the minus. So 2 minus square root of 64, still 8, over 2. 2 minus 8 is negative 6. Negative 6 divided by 2 is negative 3. So my final answers are x is equal to negative 3, least to greatest, or 5. Those are my 2 solutions. Those are my 2 roots. Those are my 2 x-intercepts. They all mean the same thing. Because these are both integer numbers, rational, that means that this could have been factored. I could have factored this into 2 binomials and used that zero product property and got these 2 answers. This is definitely a longer way than factoring, but using the quadratic formula works for every quadratic, whether it's factorable or prime. All right, let's take a look at another one. 4x squared plus 5x minus 6 equals 0. It equals 0 already. Make sure that's true. Identify your a, b, and c values. A is 4, b is 5, c is negative 6. All right, now I'll put my numbers in place. So x is equal to negative b. B is 5, so negative 5. Plus or minus the square root of b squared. That's 25. Minus 4 times a, which is also 4, times c, which is negative 6. And that whole thing is all over 2 times a. Well, this time a is 4. So 2 times 4 gets me a denominator of 8. So x is equal to negative 5. Let's do my computation inside that radical. Plus or minus the square root of 25. Negative times negative gives you positive. 4 times 4 is 16. And 16 times 6 is 96. So this is plus 96. And that whole thing is over 8. Come up here for some space. X is equal to negative 5 plus or minus the square root of 25 plus 96 is 121. Isn't that nice? That's a perfect square over 8. Anytime those numbers are perfect square, that means that your polynomial was factorable. You could have solved by factoring this, and then using my zero product property. So I'm going to split this now to two separate equations. One using plus. So be negative 5 plus square root of 121 is 11 over 8. Well, negative 5 plus 11 is 6. 6 over 8. I'm going to simplify to become 3/4. Or if you want to, depending on what the problem tells you, it might ask you for a decimal instead. It'll be 0.75. So make sure you read the directions of the problem. Does it want a fraction? Does it want a decimal? And my second answer is going to be negative 5 minus 121 square root of 11 over 8. That's negative 16. Negative 16 divided by 8 is negative 2. So my answers are x is equal to negative 2, and I'll make it a decimal, 0.75. Again, because both these answers are rational, I would have been able to factor this and find the zero product of each binomial. All right, that's part 1.